Hello guys, this video is in continuation of earlier class. We were discussing how to calculate regulation for lagging power factor load. Okay, till here we discussed that is D is equal to AB sin phi 2, that is AB can be replaced by I2 R2 is sin phi 2. Okay, so let us not bother about what they have written here. Let us directly jump to circuit diagram, that is phasor diagram. You can see that this triangle OCD is a right angle triangle, right? So if I apply Pythagoras theorem, then it will be like OC square is equal to OD square plus CD square. Okay, OC square equal to OD square plus CD square. And you can see that the angle between OD as well as OC is written as alpha. Okay, so what happens actually in practically the alpha value will be very small. So if alpha value will be very small, means what I can do is I can ignore this alpha to 0. Here for representation sake and all, they have showing like certain angle and all, okay, for understanding sake. But practically alpha value will be very small. So what happens if it is small, means I can ignore to 0. So I can call alpha is equal to 0. If alpha is equal to 0 means what happens? OC will overlap on OD. Yes, OC will overlap on OD. So Pythagoras theorem, then it will become what? OC square equal to OD square plus CD square was the earlier Pythagoras theorem. But now what happens to the formula? Since alpha is equal to 0 means this CD will become equal to 0. So what happens? OC square is equal to OD square. Or else you can write down OC is equal to OD. Right? Okay, now we can write down it as OC is equal to OD. So till here we have got everything, that is OD is equal to OA plus AF plus FD plus everything. Again I can have replaced this all things by these things. Okay, so now we came to know that OD is equal to OC. Yes, again OC value is E2. Yes, OC value is E2 and OD is equal to OC. Okay, so I can replace this OD by what? OC. Yes, I can replace OD by OC. Again I can replace OC by E2. Yes, this is the formula same I can see over here. I have replaced OD by OC and OC is equal to E2 and E2 is equal to this V2 plus I2 R2 cos phi 2 plus I2 X2 sin phi 2. It is same as that of that, right? So this is what we got EMF induced in secondary side. Again anyhow I need to calculate percentage regulation, right? So I need to write in the form of what? E2 minus V2 by V2. Yes, I need to write in the format of this E2 minus V2. So I will take V2 at the left hand side. If I take V2 at the left hand side, then I get what? E2 minus V2 is equal to I2 R2 cos phi 2 plus I2 X2 sin phi 2. Right? So this is the one, E2 minus V2. So I can replace this E2 minus V2 by this whole term, right? So I have replaced this E2 minus V2 by whole term by taking I2 as common. So in the bracket I get R2 cos phi 2 plus X2 sin phi 2. And any of V2, you know, this is the formula as per the definition. So I can write V2 as it is into 100 if you want in the percentile. Just remove 100 if you want in terms of PU. Okay, see, this stuff and all was not necessary for this derivation for till here. Anyhow, for understanding sake, you can consider this all part. Okay, but one thing you need to remember here is I am calling OC is equal to OD. The reason is alpha is small and CD is equal to almost 0. So we believe we make some approximations here. So as for the sake of derivation, so OC will be equal to OD and OD will be equal to E2. Okay, this is what we have. Percentage regulation for lagging power factor load. Now let us move on to the leading power factor load. Yes, let us move on to that. So for that, for leading power factor, one thing you should need to remember that I'm going to consider capacitive load there. So if I consider capacitive load, then what happens? Current in the secondary side, that is I2 will lead V2 by certain angle phi, precisely phi 2. Yes, yeah. So that is what I'm going to consider here. I'm going to derive the percentage regulation for leading power factor in the secondary side when refer to the secondary. So again, same thing, same as that of this. We took V2 as a reference phasor. Here also I'm going to take V2 as reference phasor. You can see OA is your V2. It is your reference. And again, one more thing I told you that current will lead the voltage. Anyhow, I'm going to consider the phasor rotates in the anti-clockwise direction. So what happens? You can see I2 is moving ahead and V2 is following the I2. So I2 leads V2 by phi 2. Okay. So that's why you can see I have written it as phi 2 angle between I2 as well as V2. The reason is because I'm going to consider capacity load here, and for capacity load current always lead the voltage. So I2 leads the voltage by a power factor angle phi 2. Hope this is clear, right? V2 is the reference, I2 is the leading current which leads by at an angle phi 2. Okay. Now we know that formula E2 is equal to V2 plus I2 R2E plus J I2 X2E, right? With respect to that formula, we can consider this Phasor diagram. You can see E2 is equal to V2 plus I2 R2E plus I2 X2E. Let us see whether it is plus I2 X2E or minus I2 X2E, because since it is a leading power factor. Okay, because we can't always say that always there will be plus I2 X2E, depending upon, it may be plus or minus depending upon leading or lagging. For lagging anyhow we have got what, plus I2 X2E, but for leading we will get what it is as minus I2 X2E. It is not just by telling, we can also prove that why we are going to get it as minus I2 X2E, not why plus I2 X2E. Fine. But for lagging, remember it is plus I2 X2E, and for leading it is minus I2 X2E as of now. We shall see that. Okay, this is phi 2, yes, and this is also phi 2, because we know that this is the alternative angle, yes or not, as per the geometry concerned. You can stretch this line to AF, and like this you can do this thing. So because of alternative angles, whatever angle is there, it will be same phi 2. You can stretch here to AF, so we can make it as right angle triangle over here, ABF. Okay, and again we know that this is I2 R2E. I told you I2 R2E is in parallel with this I2 because voltage drop it is, and I2 X2 is what, 90 degree to that current, that is I2, because reactance voltage drop, we know that current and voltage are 90 degree for the reactance. And so hope this is, you understood this phi 2. Now question arises, how this phi 2 has come into picture. Yes, how this phi 2 has come here. Okay, phi 2. This is the dotted line which I have drawn here. Again I have made a right angle triangle here. See, this all whatever we are doing, everything is for the sake of derivation. Okay, so you can see C is a perpendicular line, dotted line, and again the angle between CE as well as CB, it is what, phi 2. Let us see how is that. Okay, see I have taken have drawn a diagram here with a very similar to that. So this phi 2 you have understood, yes, phi 2 you have understood, and this will be also phi 2, and we have drawn a right angle triangle over here, so this will be 90, right? This will be 90, that is BF stands on EF by angle 90 degree perpendicular dotted line. Anyhow, it is not helping us directly, but indirectly it is helping us, okay, to get the value of this phi 2, this angle. And again we know that for a for a triangle, sum of the angles are equal to 180 degree. So phi 2 plus 90. So total angle is 180. So 180 minus phi 2 minus 90 means it will be 90 minus phi 2. So this angle is 90 minus phi 2. Okay, 90 minus phi 2. So if this is 90 minus phi 2, then this angle will be what? This angle will be phi 2, because it is Z angle. You can see alternative opposite angle. Yes, you can see this is the form of Z. So this angle and this angle will be phi 2. Okay, so this due to the Z angle, or you can say alternative opposite angle as per geometry. If this is phi 2 means this will be also phi 2. But we know angle between your I2 X2E as well as your I2 R2E is 90 degree. Yes. So total angle is 90. What about this angle then? So if I subtract 90 minus phi 2 means, so this will be what? 90 minus phi 2. I'm going to subtract this whole angle by this. So remaining angle will be what? 90 minus phi 2. Okay. And now this angle is 90 as per the geometry concerned. And we know that sum of the angles of all the triangle is equal to 180 degree. So 90 plus 90 minus phi 2 means it will be what? 180 minus phi 2 for the triangle this particular part. Exactly have missed here. C is over here. Okay, C is over here. So CDB is equal to what? Sum of the angles equal to 180 degree. But if I add 90 plus 90 minus phi 2 means it will be 180 minus phi 2. So to respect the sum of the angles of triangle as 180 degree, I need to what? Add plus phi to this, so that minus phi 2 plus phi 2 will get cancelled. So I am going to consider this angle as phi 2, so that if I add all these angles, then resultant degree will be what? Summation of degree will be 180 degree. Hope this you have understood. how this phi 2 has come. Very simple. Phi 2 is over here, phi 2 is over here, and z as per alternative angle, if phi 2 is here means this will be also phi 2, and if this is phi 2 means the total angle from this point to this point it is 90. So small angle, what about this? Deletion of 90, deletion of phi 2 in the 90, I'll get what? 90 minus phi 2, again 90 plus 90, 180 minus phi 2 plus phi 2 I need to add so as to get this angle. Let us see why we are so concerned of calculation of this phi 2 in the derivation. Okay, so hope you understood this, how this phi 2 has come. Okay, and anyhow OA is equal to V2, already we have discussed. And now coming to AF, where is AF? You can see AF is over here, since I need the value of AF here. And AF, how I can find out? AF I can find out by applying cosine formula. Okay, and this is the AF side, because since it is cos phi, phi angle, so what happens, since it is adjacent side, and this is the opposite side, and this is the hypotenuse side. Since I am bother of calculation of adjacent, so I need to apply cos. So cos phi 2 is equal to what? Adjacent by opposite, that is AF by BA or AB. So otherwise you can write it as AF is equal to AB cos phi 2. And AB length you all know, AB length is I2 R2E, so I have replaced AB by I2 R2E cos phi 2. Now coming to this BD length, where is BD? BD is over here. I am bother of calculation of this BD now. So how to calculate the value of BD now? I need to calculate BD. You can see this is the opposite side and this is the adjacent side, this is the hypotenuse side. BD is opposite means I need to apply sine formula. Yes. So sine phi 2 is equal to BD divided by BC or CB. So or also you can write it as BD is equal to BC sine phi 2. So where BC is equal to I2 x2, so I replace BC by I2 x2 sine phi 2. And again BD is equal to EF, yes or not? This length is equal to this length, EF. Okay, so I got AF length, OA length as well as EF length. Okay, now with that knowledge we can write it as this formula here, OE plus EF is equal to OA plus AF. Yes or not? See, OE plus EF, okay, OE plus EF is equal to what? OA plus AF. True, yes or not? Very much true. Again I'm going to, anyhow I need to have the value of OE here. So OA value already know, OA I have replaced by V2, this already we know. Again AF already we calculated, I2 R2E cos phi 2, and EF value again already we calculated here, that is I2 x2E sin phi 2 minus, because minus sign is over here. And now what about CE? Where is CE? You can see that C is over here and E is over here. So CE is equal to CD plus DE. Can I write like this? CE is equal to CD plus DE, and CD length is how much? CD length is I2E x2E cos phi 2. How you got this? Because since it's an adjacent side, and if you want to calculate adjacent side means you have to apply cos formula. So cos is equal to what? Cos phi 2 is equal to adjacent by hypotenuse, that is CD is equal cos phi 2 is equal to CD by CB. So CD is equal to what? Cos phi 2 into I2 x2E. Hope you understood this, how this formula come. So CD is equal to I2 x2E cos phi 2. Okay, and now coming to DE, what about DE? Where is DE? Just see, DE is over somewhere here. Okay, DE length. So how to calculate DE length? If I know BF length or FB length, so I can calculate what? The value of DE. Okay, so FB length is equal to DE. So how to calculate FB length? Did we calculate that? No, I guess. Okay, so FB how I can calculate here, since it is phi and since it is opposite side, so I need to form in the form of what? Sine, because I need opposite side. So sine phi 2 is equal to what? FB by AB. So FB is equal to AB into sine phi 2. So that's why you can see here FB is equal to AB into sine phi 2, and again FB is equal to D. So AB into sine phi 2. So AB is nothing but what? AB is nothing but I2 into R2E and sine phi 2. So that's why D is equal to I2 R2E sin phi 2. Okay, and one more thing here, the angle between OC as well as OF, you can write it as alpha here, and you can say as we know that alpha value is always very small, you can ignore to 0 just like we did in the earlier class. So CE, so what happens for this? What happens? The value of C will be 0. Yes or not? Because if I consider alpha is over here, then again if I want to say alpha is equal to 0 practically, then C will be 0. This OC will overlap on OE. So C is termed as 0. Okay.